motion. So, see what is motion actually? When do you say any object is in motion? When do you say any object is at rest? So, see here, whenever any object is changing its position with respect to its surrounding. Suppose you are standing at a point and one person is moving around you. You measure its position with the time, you will find that person is at different positions at different time. So, you can say that person is in motion with respect to you. So, you can consider your position as origin, that is actually called reference point, and then the position of that person who is moving around you. You can find his position at the different times, and you can say okay, that object is in, that person is in motion. Now, when that fellow is not changing his position with the time and with respect to you also, then you can say that person is at rest with respect to you. So, see, any object which is in motion or any object which is at rest, it is not necessary that object is at rest or in motion with respect to other points. For example, if you are taking reference point moon, somebody is on the moon and observing our position. We are standing in a classroom. So, both of we are at rest with respect to each other, but the person who is observing from the moon, he will find earth is in motion. So, we are in motion. Equations of motion using graphical method. That means using graphs. So, you have to derive equations of motion using graph. So, say here, first we have to draw graph between velocity and time. Here I have taken velocity in this axis. Here this is O, we can take here time in this axis. Suppose graph is like this. We can take this is a initial velocity u, and here this is final velocity is v. Now, we can give this name, this is A, this is B, and we can draw like this here perpendicular here, this point can be said C. Now, I can draw one line over here, this can be given as D. So, see here, first we can take slope of this graph. Here we can write BD is equal to this much BD. From here to here this is V, from here to here this is U. So, we can write BD is equal to V minus U. This I have taken 0 time here, and this we can take as T. So, we can write AD is equal to T minus 0, that is equal to T. So, now we can write slope of VT graph is equal to BD upon AD. Here we can write BD upon AD is equal to V minus U upon T, which is equal to acceleration. We have done already, this thing is here. So, now we have got slope from this graph, that is V minus U upon T is equal to A. Now, we will write this equation in another form. So, we can write here V minus U upon T is equal to A here. So, we can write V minus U is equal to AT. So, we can write V is equal to U plus AT. So, see here, this is the relation between velocity, acceleration and time, but acceleration remains uniform, and this relation is known as first equation of motion. You can say first equation of motion, otherwise you say better relation between velocity, acceleration and time. So, now this was the first equation, you can refer as first equation. Now, we can derive another relation, we can find distance from here. So, now we will derive formula for the distance or displacement. So, now we can calculate distance or displacement from this graph. So, we can calculate here distance travelled in time t is s is equal to, I have told already, to calculate distance we have calculated the area between velocity time graph and time axis. It means this whole area. So, we can write here area of OABC. So, area of OABC. This we can divide area into two parts. So, one is rectangle, one is triangle. So, we can write here S is equal to, that is the distance or displacement you can say. Here area of OADC rectangle plus area of triangle ABD. Here we can write OA into OC plus this area of rectangle, area of OABD, triangle ABD, we can write half into AD into BD, base into height simply. So, now put the value of OA, OA is U, OC is equal to T. So, we can write into T plus half AD is again equal to OC, that is into T. BD already we have calculated. So, BD we can write here, that is equal to V minus U. So, we can write V minus U over here. Now, see here, we have done V minus U is equal to AT. So, we can write here S is equal to UT plus half T into AT. So, it is S is equal to UT plus half AT square. This is the relation between displacement, initial velocity, time and acceleration. So, basically velocity, displacement and time. Now, similarly we can calculate relation between velocity and displacement, that means without time, there is no time. For that we can take again from here. So, I will use the same graph which we have used for the other two equations. This equation actually referred as second equation of motion. So, now for the third one we can write again area of trapezium OABC is equal to displacement. So, here we can write area of trapezium, that is equal to displacement, we can represent it by S. So, we can write S is equal to, what is the area of trapezium? Sum of the two parallel sides, it means OA plus, we can write BC, these are the two parallel sides, into height is AD divided by 2. This is area of trapezium. Now, put the value of all these. S is equal to OA, we can write U plus BC, from here to here we can write V, AD is time divided by 2. Now, I can take this step to this side here, we can write S is equal to U plus V by 2 into T, we can write V minus U upon A, using V minus U is equal to AT. So, we can write T is equal to V minus U by A. So, using this relation we can replace the value of T. Now, we will solve this. S is equal to, we can write V square minus U square upon 2A. So, we can write here V square minus U square is equal to 2A, 2AS, S is multiplied. So, V square is equal to U square plus 2AS. So, this is the relation between velocity and displacement and acceleration without time. This equation we can call as the third equation, but not necessary to name equation 1, 2 and 3. we have to actually learn by this the relation between velocity, acceleration and time, relation between displacement, velocity and time, and relation between velocity, acceleration and displacement, no time. Now, see this example. A car starting from rest accelerates in a straight line at constant rate of 3 meter per second square for 8 seconds. How much does the car travel in this time? So, you have to calculate distance. Now, first you see what quantities are given in this question. First one, car starting from rest. It means initial velocity is 0. So, you can write u is equal to 0. Now, accelerates in a straight line at constant rate. Constant rate means uniform acceleration. A is equal to 3 meter per second square. Now, for time 8 seconds, time you have got 8 seconds. You have to calculate distance. So, you have to find distance. So, I have put here question mark. Now, look at all the three equations which tells relation between all these and where we can calculate directly. So, now see second equation of motion, relation between displacement and time. So, you have done S is equal to ut plus half at square. Everything is given in this question. S is equal to u is 0 into 8 plus half into 3 into 8 square, that is a square of 8. So, now we can write a 0 ho gaya, that is 0 plus half into 3 into 64, and this you can take here 32. So, 96 meter. So, distance travelled in this time by the car is 96 meter. Let us see another example. See this example. A bus starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and distance travelled by bus for attaining this velocity. So, now see in this question, bus starting from rest means u is equal to 0, attains a velocity of 72 km. This is final velocity. V is equal to, we can write 72 km per hour. Time t is given to you 5 minutes. As I have told you, SI unit of time is second, SI unit of velocity is meter per second. So, better we can convert all these things in SI unit. So, time we can write 5 into 60, that is 300 seconds. Here velocity we can write 72 into 1000 divided by 3600 meter per second. So, this will get cancelled, and here this is 5, this is 18, this is 4. So, that is 20 meter per second. Basically, when you want to convert kilometer per hour into meter per second, just to multiply by 5 by 18. I have done with the proper steps, but you can directly multiply by 5 by 18. So, final velocity is this, initial velocity is 0, time is this. Now, you have to calculate acceleration. You know, first equation was v is equal to u plus at. Here we get final velocity is 20, initial is 0 plus a into 300. So, we can write a is equal to 20 by 300 meter per second square. So, this 0, this is here 1 by 15. So, a is equal to 1 by 15 meter per second square. Now, we can calculate distance. We can apply the third equation, third relation that we did. V square is equal to u square plus 2as. Here we have done v is 20, square is equal to 0 plus 2 into 1 by 15 into s. Square of 20 is 400. is equal to 2 upon 15 into s. So we can write s is equal to 400 into 15 divided by 2. This is here 200. So we can write s is equal to 3000 meter. See this example. A stone is thrown in a vertical upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in downward direction, what will be the height attained by the stone and how much time will it take to reach there? Now see, this question is different than the previous questions. Whenever we throw any object, suppose you are throwing this pen like this vertically up, what happens? As the body goes, slowly its speed keeps on decreasing. At a certain height, its velocity becomes 0. So when you throw a ball like this, I am taking this example, with the certain speed u, as it goes up, velocity decreases and ultimately finally it comes to rest here, final velocity is 0. But in this process, one force is acting vertically downward, that is called gravitational force or gravity of the earth. Because of that, this body has acceleration downward, and this acceleration is downward. Here we can write downward acceleration, but this acceleration is opposing this velocity. So this we can call here it is acting as a retardation. So, and when the body comes down, it accelerates in the direction of velocity. We can take positive. When it goes, body goes up, we can take this acceleration negative. This downward acceleration represented by g, and its value is constant, we take 10 meter per second square, or we can write also 9.8. This is also known as acceleration due to gravity. Acceleration due to gravity. So when the body is thrown vertically up or it is dropped from a height, we use this acceleration. If the body is going up, we use this value negative. When the body is coming down, we use this value as positive. Now by using this concept, you have to solve this question. So now see here, solution of this question here. What you are given here, u is equal to 5 meter per second. Body is going up, reaching at maximum height, final velocity will be 0. So we can write v is equal to 0. And now you have to take acceleration, a is equal to, we can take g is equal to minus 10 meter per second square, because we are treating as retardation because the body is going up, acceleration is acting downward. Now first we have to calculate height attained. See here, v square is equal to u square plus 2as. We can replace all these values here, 0, here 5 square plus 2 into minus 10 into s we can replace by height h. So here I have written s is equal to h. Now we can solve it. It is here coming minus 25 is equal to minus 20 into h. So h is equal to 25 by 20, that you will be getting here 1.25 meter. It means body will be going to the maximum height of 1.25 meter. At 1.2 meter height, the body will come to rest momentarily and then it will start coming down. Now we have to calculate time also, very simple. We can use v is equal to u plus at, that is 0 is equal to 5 plus minus 10 into t. So we can write minus 5 is equal to minus 10 into t. So t is equal to 1 by 2 seconds. So the body will take time 1 by 2 seconds, that is 0.5 seconds to reach the height of 1.25 meter. So this question was entirely different than the previous questions, because I have told you the new concept, that is using of acceleration due to gravity. Actually this concept is not in this chapter, it is in the gravitation chapter, but for certain numericals we can use this concept. Certain questions are given in NCERT book related to this. So, now we have done examples related to equations of motion. Now we will do uniform circular motion. See, till now we were doing motion along a straight line. Now we have to take circular motion. So, first we will discuss here uniform circular motion. It's very simple example. You take a stone, tie with the thread and keep on moving like this, just revolve like this. So, this stone will travel like this path. So, this is the center, and when the body moves in a circular path, this one, we say body has circular motion. So, now see here in uniform circular motion, certain things are very important here. Suppose you have taken the point A from where motion starts. Now, we can take at here origin t is equal to 0, 0 time. As the body starts moving from here, it comes to here, 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 here and here, ultimately comes back to this position. This circular path, everywhere you will find when the body is here, direction of velocity is like this. When the body is here, direction of velocity is like this. When the body is here, direction of velocity is here. So, every time direction of velocity keeps on changing. So, here if speed of the body, that means magnitude of velocity of the body remains constant, but direction of the velocity is continuously changing. Because of the change in direction, there is change in velocity. As velocity changes due to change in direction, there is change in acceleration. So, in this case, if it is a uniform circular motion, speed of the body remains constant, whereas velocity changes due to change in direction. As a result, acceleration changes. Therefore, this motion is said to be accelerated motion. So, see here what is the definition of now uniform circular motion. Now, just I will repeat the definition. When the body moves in a circular path with a constant speed, motion is said to be uniform circular motion. Another example here, is this motion said to be accelerated? Yes. This motion is said to be accelerated because change in direction takes place, and as a result velocity also changing here. If this circular path has got radius r, so we can write distance traveled in one revolution is equal to 2 pi r. Suppose time taken to complete one revolution is t. So, total distance in one revolution you have got 2 pi r, total time to complete one revolution you have got t. So, now you can calculate velocity easily, that is 2 pi r upon t, that is velocity upon distance upon time. So, here we can do this, but now example related to this, like earth is revolving around the sun. So, we can assume orbit of earth is circular, we can take its time period and calculate its speed. Similarly, moon is revolving around the earth, we can take its time period and we can calculate its speed. So, these are the examples where we do all these related to circular motion, and this one there are certain topics related to this like angular displacement and angular velocity, which I am not telling here because it is not in this syllabus also here in 9th standard. But when the body moves in a circular path, it has got linear velocity as well as circular angular velocity. You know, angular velocity, I will just give you information about this. Angular velocity is represented by this symbol is pronounced as omega is equal to theta by t. Angle upon time is the angular velocity. Here we measure angle. Angle is measured in radian. So this is about angular velocity, and v is known as linear velocity. So we can also write relation between linear velocity and angular velocity. This relation is simply v is equal to omega into r. So here v is linear velocity, omega is angular velocity, and r is the radius of the circle. So now we will do examples, that means questions related to this in next slide. Now see this example. There is a graph between distance and time. Here time is given in seconds, distance is given in meters. If I ask you to calculate speed between third and fourth second, so now you have to calculate distance between third and fourth second. So we can take this example, just I have drawn this line and this line. See, this is the time interval, this is the distance, so this we can take b and this we can take c. We can write AB is equal to 4 minus 3 is equal to 1 second. BC is equal to, we can write 20 minus 15 meter is equal to, that is 5 meter. So now we can write speed is equal to 5 divided by 1 meter, that is second, is equal to 5 meter per second. This we can say BC upon AB, which is equal to slope of distance time graph. Now see here, whatever time interval you take, every time you will be getting speed is constant. Suppose if I take another example, calculate speed between 0 and 5 seconds. So speed between 0 to 5 seconds. How can we calculate? See, 0 to 5 seconds, total time interval is 5 seconds, total distance is 25 meter. So we can write speed is equal to 25 upon 5, that can be said average speed also, 25, that is 5 meter per second. So whatever time interval you take in this example, you will be getting speed remains constant. So for uniform motion, graph is a straight line and speed remain constant. Now if you want to calculate acceleration from this, so what is acceleration? Acceleration A is equal to, you can write change in velocity, that we can write v minus u divided by t2 minus t1. So final and initial speed will remain same throughout the motion, time interval changing. So you will be getting here 0 upon t2 minus t1 is equal to 0 meter per second square. So acceleration for this uniform motion is 0. Now we will take an example of circular motion. Now see here, an artificial satellite is moving in a circular orbit of radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the earth. You know, as its satellite is revolving around the earth, so this is an example of circular motion. Here we have to calculate its speed. So what we can do here, first we know it, formula of speed is v is equal to 2 pi r upon t, where 2 pi r is the circumference. It means if you have taken this is the center, OR, this is complete circumference, and t is time taken to complete one revolution. So here we can write v is equal to, r is given to us, 2 into pi into 42,250 divided by 24. we can put value of pi. Pi is equal to 3.14. So, we can write V is equal to, if you multiply all these things, you will be getting 265330 divided by 24 kilometer per hour. If you solve it, you will be getting 11055.41 kilometer per hour. Now, we can convert this kilometer per hour into meter per second. So, divide by 3600. So, we can get here V is equal to 3.07 kilometer per second. So, speed of the satellite in its orbit is 3.07 kilometer per second. So, this is an example of the circular motion where we can apply formula V is equal to 2 pi r upon t. Now, rest about circular motions we have done. There are many examples like clock's hands, like a minute's hand, second's hand and hour hand we can take, and also they are performing circular motion. If you take example of fan, it is also moving in a circle, blades are moving in circular paths. So, there are many examples of the circular motion, but there are in this 9th standards not much in details. So, whatever are given or whatever we have discussed, you have to do only this much. So, now we can discuss one or two more examples related to graphs, where we can tell which object is moving fast or which object is moving slow just by seeing graph. Now, take another example. In this example, I have taken distance time graph. See here, this is x axis, this is y axis. Here I am taking time t, and here this is origin, and here we have taken distance. Now, if you have taken three graphs like this, like one is like this we can refer as graph A, another is like this, graph B, another we can take here graph C. If you see these three graphs, here all these three graphs are a straight line, all these three are showing here uniform motion, that means uniform speed. Now, you have to tell which object has greater speed. Just by knowing the slope of the graph, we can tell which object is moving with the greater speed. So, see here there are three graphs 1, 2 and 3. In the graph only it is visible graph C has got highest slope. So, the object for which graph C is representing, that has greater speed. So, just by seeing the slopes we can tell which object has greater speed, which object has slow speed. Now, take another example. Here if we take, suppose distance time graph is like this, here x axis, here is y axis, there is distance, there is time, this is O, and the graph is like this, and in that case we can take graph is like this is A and this is B. Here again there are two objects, for one object graph is A, for another object graph is B. Now, out of these two, which one has got greater speed? Obviously, graph B has got greater speed because it has greater slope. We can check slope just by seeing the angle. If you draw the angle with the x axis here this and here this, you will find this angle is greater than this. So, just by seeing the angle you can tell which object has got greater speed. Now, in all these examples whatever I am discussing, just by seeing the graph you have to tell which object has got greater speed, which object has got slower speed. There are many examples related to this related to these graphs in the book, you can do them, and whatever the doubts are there you can discuss, but see here, try to understand each and every concept very carefully and give proper time to each and every point. Now, by this way this chapter motion is over. Now, we will start next chapter, that is force. Another example, like a person is sitting in a moving bus, he sees trees, plants, everything are in moving in opposite direction. But if you are standing on the ground and you observe position of the trees and plants, you will find they are at rest. So, the same tree is in motion for the person who is sitting inside bus, but the same tree is at rest the person who is standing on the earth. So, here we study relative motion, because you can't say any object is absolutely at rest. So, for relative motion I have given one example of the bus, one example of the moon. So, for describing the motion we need two main terminology. First one is distance and displacement. So, first we will discuss distance and displacement. So, see here what is distance and what is displacement. So, see distance and displacement you can understand. Suppose any object is at this point A, this I have taken starting point or the reference point, and object goes A to B, the distance is, suppose this is 3 meter. Now, from B to C, just at 90-degree object takes turn and goes to the point C. This distance is 4 meter. Person is moving from A to B, then B to C. So, measure length of path. This is 3 plus 4. So, length of path is equal to AB plus BC. So, you can write here 7 meter. But if you see this distance, here I have taken right angle triangle. So, we can take this is AC directly here. If you find AC, AC will be here under root of AB square plus BC square, that will be 3 square plus 4 square, it is equal to 5 meter. So, AC is 5 meter. So, if you see AC, it is the 5 meter. So, now see here the length of the path is known as distance, A to B, B to C. If you add these two lengths of path, this is called distance. But this is initial position, we know it, initial position. This we can refer as final position. So, the shortest distance between initial and final position is known as displacement. So, AC is known as your displacement. So, in this example, distance is 7 meter, whereas displacement is 5 meter. So, see, distance is the length of the path traveled by a body, whereas displacement is the shortest distance between initial and final position. Now, displacement may be 0, but distance cannot be 0. So, see here for example, if you have taken this point is as origin, that means it is a reference point from where you are going to study motion of an object. An object is here, you know, we can take point sized object. So, in what cases we take point sized object, that I would like to tell you right now. So, see here, sometimes we can consider train is also as a point sized object, bus is also as a point sized object, car is also as a point sized object, a very small object is also considered as a point sized. But what are the conditions when we consider train as a point sized object? Suppose train is traveling very large distance, 2000 kilometer, 3000 kilometer, whatever you can take. So, whenever the distance traveled by the object is much larger than the size of the object, then the object is considered as a point sized object. So, now I have taken a point sized object at origin, this I have given as point O. Here we are ignoring size of the object. Suppose object is going O to A, this distance is suppose 2 meter. Now, object is going A to B, this distance is suppose also 2 meter. Now, object comes back from B to A, and then A to O. So, object is started from O, went to the point B and came back to the point A and then came back to the point O. So, if you find the shortest distance between initial and final position, so you know here the initial and final position both are the same thing, and that is on origin. So, in this case we can write displacement is equal to 0, because object started from O, went to B and came back to the point O. So, initial and final positions are coinciding, so we can say displacement is 0. But you see distance, how can you write distance here? So, see distance is going O to A, OA plus O to B plus AB, because it is going A to B, then coming B to A, then it is coming A to O. So, the distance is 2 plus 2 plus 2 plus 2, this is equal to 8 meter. So, here displacement is 0, but distance is non-zero, that is 8 meter. Distance and displacement both are measured by the same unit, that is called meter. So, SI unit of distance and displacement is meter. So, now we will study another example related to this. Suppose you have taken motion of an object in a circular path. Suppose this is a center of the circle, we can give at O. Any object start from the point A moving in a circle like this. This radius I have taken suppose R, and this was position, initial position A. Object has started moving from A, going to the point B, then coming to the point C, then coming to the point D, and ultimately coming back to the point A. So, radius of the path is circular path is R. So, object is starting to move from A and coming back to A. So, again you can write displacement is 0 when object completes one revolution. But what is distance? Distance I have told, that is length of the path. So, from A, this whole circumference of the circular path is equal to distance. So, here we can write distance is equal to circumference of circle, that is equal to 2 pi r. So, here displacement is 0, but distance is non-zero, that is 2 pi r. Similarly, if the object is going suppose A to B here, what will be distance and what is displacement? If the object is going directly A to B, so this path is known as distance and this one is known as displacement. So, here since you know this is 1/4 of the whole circle, so for this case you can write distance is equal to 2 pi r upon 4. So, that will be here 2. So, pi r upon 2. So, when the object is going A to B, distance is pi r upon 2, but what is the displacement? Displacement we can write by Pythagoras theorem, this is r and this is r. So, AB is equal to, we can write r square plus r square, that is 2r square is equal to r under root 2. So, here displacement is this, which is r under root 2, whereas distance is pi r upon 2. Similarly, when the object is reaching to the C, distance is pi r, half of the 2 pi r, whereas displacement is r plus r, that is we can write 2r. So, see, for distance and displacement we have seen 2-3 examples. Now, here distance, whenever we need to describe, we just need magnitude, whereas displacement requires magnitude as well as direction. So, there are the two quantities, one are called scalars, another are called vectors. These quantities like scalars and vectors, we will study in just now in next slide. So, now we will study about scalar and vector quantities. So, see here scalar and vector quantities. See, what are scalars? Scalar quantities are required just magnitude for their descriptions, whereas vector quantity required magnitude and direction. So, see, for scalars we just need magnitude, for vectors we need magnitude and direction. Here you can take examples like distance, mass, speed, etc. Here we can take example displacement, velocity, force, etc. So, see, these quantities whenever are described, they need magnitude as well as direction, whereas these quantities do not require magnitude or directions for their description. So, for example, I am discussing first vector quantities here. As I have told, they need magnitude as well as direction. You cannot add algebraically these quantities. We need actually vectors rule, vectors addition, vector subtraction, that you are not going to do in this chapter or in this class, that means in 9th class. But here magnitude, when you are studying, this is a scalar quantity, only magnitudes are required. Here distance, mass and speed, you can add algebraically these quantities. Now we will come to the first point here, that is called speed. What do you know about speed? See here, whenever any object is changing its position with respect to time, so the rate of change of position, you can say that is speed. So, speed is equal to distance upon time. So, distance travelled by the body per unit time is known as speed. So, now see velocity. Velocity is equal to displacement upon time. So, you have done displacement can be 0, therefore, velocity can be 0, whereas speed here distance cannot be 0. So, here speed cannot be 0. Distance and displacement both are measured in meters. So, their SI unit is SI unit of speed and velocity is meter per second, or you can write m as raised to power minus 1. That is the same way to write a meter per second. So, speed and velocities are actually different only in terms of the direction. Velocity is a vector quantity, whereas speed is a scalar quantity. Now, we will see about average speed. So, average speed and average velocity. So, here average speed is equal to total distance travelled divided by total time taken. Suppose you are moving from one place to another. Suppose you are going from Delhi to Agra. You have taken 4 hours. So, you just find total distance travelled and then divided by the total time taken, you can get average speed. Now, average velocity is equal to total displacement divided by total time. So, here just to find total displacement and divided by total time, you can get average velocity. So, now as I have told, both are measured in meter per second or in kilometer per hour. You can say also these average speed and average velocity, or speed and velocity. So, now we will take examples of average speed, average velocity and the speed and velocity. So, how do we calculate in different cases these average speed and average velocity? Now, we will study in examples. Now, see example 1. An object travels 20 meter in 4 seconds and another 20 meter in 2 seconds. What is the average speed of the object? So, see here, total distance first to find. This is 20 meter and 20 meter. It's very simple example. So, total distance is equal to 40 meter. Then total time taken is 4 plus 2, that is 6 seconds. So, now what is average speed? Average speed is equal to 40 meter divided by 6 second. We can cancel it here. Simply this is 20 and this is 3. So, 20 upon 3 meter per second. So, now you can also write here 6.6 meter per second. So, this is average speed of the object. Now, see next example. See in this example, a man goes to market from his house covering 2 kilometer distance in 30 minutes and comes back in another 30 minutes. What is average speed and average velocity of man? So, now see here, first to find total distance. So, total distance is, say 2 kilometer going to market and 2 kilometer while coming back. So, 2 kilometer plus 2 kilometer, that is equal to 4 kilometer. Now, total time is equal to 30 minutes while going plus 30 minutes while coming back, that will become 60 minutes is equal to 1 hour. Now, what is average speed? So, average speed is equal to total distance upon total time, that means 4 kilometer divided by 1 hour is equal to 4 kilometer per hour. So, kilometer per hour can be also used to represent speed. Now, we can write average velocity. So, average velocity is equal to total displacement upon total time. So, now see what is total displacement in this case. A man has gone to his gone to market and coming back, it means initial and final position is same. So, total displacement is 0 divided by total time is 1 hour, that will be equal to 0. So, average velocity is 0. So, here an example where average speed is non-zero, whereas average velocity is 0. So, now these were two simple examples. Now, see the next example, which is slightly difficult one, or you can say which slightly needs more skill to solve it. So, you try to do that example. See in this example, a car travels certain distance with a speed of 40 km per hour and comes back with a speed of 50 km per hour. what is his average speed and average velocity? Say in this question, you are not given distance and also you are not given time. You have to calculate average speed as well as average velocity, for which we need total distance as well as total time. Both are missing here. So, now we have to solve this question by assuming distance, let it be x, y, whatever you want you can assume. Suppose object goes A to B. This distance is suppose x kilometer and the man is going, car is going with a speed of 40 kilometer per hour, A to B. While coming back, the speed is 50 kilometer per hour. So, now see here, while going travelling distance x, while coming back travelling distance x. So, you can find total distance. So, total distance covered, or you can write travelled, is equal to x plus x kilometer, that is 2x kilometer. What is total time? So, now we know speed is equal to distance upon time. So, we can write time is equal to distance upon speed. Here we have assumed distance x, so we can now calculate time. So, while going A to B, time will be distance upon speed, that means x upon 40, while coming back B to A, time will be x upon 50. So, total time can be written, total time is equal to x upon 40 plus x upon 50, that should be here 200 LCM. So, we can write 5x plus 4x, that is 9x by 200 hour. So, this is total time taken here, 9x by 200 hour. So, we can calculate average speed. Average speed, this is total distance divided by total time. So, we can write average speed is equal to 2x divided by 9x by 200, 200 will come up here as a numerator, this x will get cancelled, it is 400 by 9 is equal to 44.4 kilometer per hour. So, this is average speed. Now, we can calculate average velocity. So, average velocity can be written total displacement upon total time. You know the body has gone to the certain distance and come back again to the same position. So, displacement is 0, and whatever is the total time taken, that you can write here 9x by 200. So, that will be equal to 0. So, average velocity is 0, whereas average speed is 44.4 kilometer per hour. So, in this case, this type of example where distance and time both are missing, you can assume distance and you can calculate all these things. So, these are the examples related to average speed, speed and velocity and average velocities. Now, one more thing is here, some student may assume 40 plus 50 divided by 2, they can take average of these two speeds. Like they can write directly average speed is equal to 40 plus 50 divided by 2, that is 90 kilometer per hour. So, sorry, not 90, that is 90 divided by 2. So, it is here 45 kilometer per hour. They can write, and also you can commit this mistake, but see, this formula is not applicable here. This is wrong concept for this. This formula only can be applied if the speed is changing at constant rate or velocity is changing at constant rate. If speed and velocity is not changing at constant rate, you cannot apply this formula. So, do not try to use this formula in this type of the question, unless you are given rate of change of velocity is constant, that remains same. That means we can say actually acceleration is uniform, which we will do later on, but for applying this formula, be careful. Now see uniform and non-uniform motion. See, we have done speed and velocity. We have done speed every time we have taken constant speed and constant velocity, but in daily life it is not obtained. Whenever you are driving your car or you are riding your bicycle, you will find you cannot maintain constant speed. Sometimes maybe the speed 10 km per hour, sometimes maybe 20 km per hour. So, speedometer of the car shows the speed, but it is a different and different moment. That speed is known as instantaneous speed. Now, here when the object changing its speed in the time, a regular time interval, we can say the motion is non-uniform. If speed remains constant in all intervals of time, then we say motion is uniform. So, we can conclude here, whenever any object travels equal distances in equal intervals of time, we say object is in uniform motion, and whenever any object travels unequal distances in equal intervals of time, we say motion is non-uniform. We can represent these two motions, uniform and non-uniform motion, with the help of graph. Suppose you have taken, this is x axis and this is y axis, and you take here time intervals in this axis, and here in this axis you take distance. If body covering equal distances in equal intervals of time, then the graph obtained will be like this, that is a straight line. This graph is for uniform motion. So, whenever you are getting graph between distance and time is a straight line, motion is uniform. Now, we will take another graph for non-uniform motion. Suppose you have taken graph like this is x axis, this is y axis. Here you have taken time, and this is your 0, and here you have taken distance along this, and graph is not like this. That means not like a straight line. You are getting graph like this. This is graphical representation for non-uniform motion. So, there are two types of motion, uniform and non-uniform. Here body is covering equal distances in equal intervals of time, and graphically graph between distance and time is a straight line. Here graph between distance and time is not a straight line. Here maybe the distance is unequal. So, the not necessarily graph is like this only, graph may be like this, maybe in any way, but not a straight line. So, now we will do what happens in uniform and non-uniform motion. How do we calculate speed? How do we calculate their rate of change of velocity or speed? We have to do in this next topic or the next slide. See, next topic is acceleration. See, acceleration is simply the rate of change of velocity is called acceleration. So, the rate of change of velocity is known as acceleration. Acceleration is equal to, we can represent by small a like this, is equal to change in velocity upon time interval. So, acceleration is equal to change in velocity upon time interval. We know it, change in velocity, that means velocity we can measure in meter per second, upon time interval is only second. So, its unit is unit of acceleration is equal to meter per second square, or we can write meter per second square in this way. See, the SI unit of acceleration is meter per second square. Now, see a change in velocity, as I have told you, acceleration is equal to change in velocity upon time interval. Suppose you have taken initial velocity is u, final velocity is equal to v, and we can write here initial time is equal to t1 and final time is equal to t2. So, you can write acceleration A is equal to v minus u upon t2 minus t1. So, see here, final velocity may be greater than initial velocity, not necessary it is less. So, if v is greater than u, the value of A you will be getting positive. This is called positive acceleration. We say only just acceleration. It means speed is that velocity or speed is increasing with the time. But if final velocity is less than initial velocity, suppose initially car was moving at a speed of 50 km per hour. After some time it is moving with the speed of 20 km per hour. Now, speed has gone down. In this case, value of acceleration will be coming negative. This negative acceleration is known as retardation. So, retardation is basically negative acceleration. So, acceleration means whenever speed increases with the time, we say acceleration. Whenever the speed or velocity decreases in the time, we say retardation, that is negative acceleration. But see here, every time I am using velocity and speed for the same term, because in certain cases speed and velocities are same. Suppose if the body is moving in a straight line, I am giving you an example related to this. If body moves in a straight line, suppose body is moving from O and it is going O to A in 1 second, and distance is 1 meter. A to B, this is again 1 meter, this time is 1 second. So, body is moving in a straight line. This motion is known as a straight line motion. In this case, when the body goes O to B, distance is 2 meter and displacement is also 2 meter. Similarly, when you calculate speed, this is total distance, that is 2 meter upon 2 seconds, that is 1 meter per second. Similarly, velocity is also 1 meter per second. So, when the body moves in a straight line, then distance and displacement are equal. Similarly, speed and velocities are equal. So, for a straight line motion, we can refer the speed and velocity for the same terms. Now, we will discuss here about the calculation of velocity and speed from the graph. See, it is very important topic and you have to concentrate on this part because it is a graphical relationship. So, now as we have done for xt graph, that is called distance time graph, for uniform motion. It was like this here. Here I took time and here I have taken distance. This is 0 point. Graph, I have told it was a straight line. Now, if you want to calculate speed from this graph, we can say speed and velocity because I have considered straight line motion here. So, we can take any 2 points. Suppose corresponding point for this is time is t1 and for here time is t2, and the distance for this is x1 and the distance for this is x2. So, for time t1 distance is x1, for time t2 distance is x2. Now, what you do? You just draw this line here. You will be getting this one is t2 minus t1, and we can take this is A, this is B, and this is C, and this BC is whole is x2 and this is x1. So, we can write x2 minus x1. So, now here speed is equal to speed in time interval t2 and t1. So, we can write x2 minus x1 upon t2 minus t1. We can write it here BC upon AB. This we can say slope of distance time graph. So, slope of distance time graph represent speed. If the body is in a straight line, then it also can be said to be equal to velocity. So, see here x2 minus x1 and t2 minus t1 here, just we have taken distance upon velocity, we can say this one. This is the distance travelled in t1 to t2 seconds. Now, we can also write this is angle is theta. So, this also angle is theta here we can take, since these two are parallel lines. So, this theta is also equal. So, here by calculating the slope you can calculate speed of the body and velocity of the body. Now, we will do by taking examples how do we calculate speed and velocity from the given graph. Now, we will do velocity time graph for uniform motion. Velocity time graph for uniform motion. See here we take x and y axis, this is x axis, this is y axis. Here we take time, this is called time axis, this is origin, and here we take velocity. Now, you know it, in uniform motion velocity remains constant, velocity or speed you can say both remains constant. So, we can get graph like this. So, this graph represent velocity time graph for uniform motion. Now, from this graph you can calculate distance travelled by the body. Suppose you want to calculate distance travelled, so we can take this point, this is suppose t2, and this we can take any point is here, that time we can take it is t1. We can give this is A, B, C and T. Now, here this velocity which is constant, that is V here. So, now from this graph we can calculate distance travelled between the time t2 and t1 just by calculating area between velocity time graph with the time axis. So, you are calculating displacement or distance between t1 and t2. So, just you calculate area of this shaded portion. So, area of ABCD is equal to AB into AD, that is actually a rectangle here. So, we can write AB is equal to velocity and AD we can write T2 minus T1. This gives magnitude of displacement. Now, if it was speed you can write distance also here. So, we can calculate distance or displacement by using velocity time graph. Now, we will do non-uniform motion. As we know, non-uniform motion is that motion in which distance travelled by body is unequal in equal intervals of time. We have done this graph earlier like this. Here we took time t, here was distance and the graph was like this. This graph represents non-uniform motion. It means this is distance time graph for non-uniform motion. See here, when body is traveling unequal distances in equal intervals of time, suppose it is traveling more distances in the equal intervals of time, every time distance is increasing, we can say body is accelerating, body has acceleration. So, when the body has acceleration, so we can draw velocity time graph for the body having uniform acceleration. So, now we will take uniform acceleration. So, velocity time graph for uniform acceleration. Velocity time graph for uniform acceleration. Here I have taken in this axis here time, this is x axis, this is y axis, we take here velocity. Now graph is like this. This graph is straight line, shows that there is a equal change in velocity in equal intervals of time. Now from this velocity time graph we can calculate acceleration. Suppose you have taken 2 points, one is here, this time is t1, this time is t2, this we can take A and B. Now we join this is C. Here we can write BC is equal to, this is the velocity axis, so we can take this is V2 and this we can take here V1. So here we can say BC is equal to V2 minus V1 and AC is equal to T2 minus T1. Now we can calculate slope. Slope of VT graph, that means velocity time graph, is equal to BC upon AC, that is equal to V2 minus V1 upon T2 minus T1. We can say that is called acceleration. So when the body has acceleration, motion is actually non-uniform because distance traveled in equal intervals of time will be different. So this is the velocity time graph for the non-uniform motion, but it is a uniform acceleration. Calculation of acceleration by using graph, and this is actually slope of the graph, and which I have found here in this triangle. You can take whole triangle also like this is here complete from here, and you can calculate acceleration. Whatever time interval you will take, acceleration will remain same. So now we will see velocity time graph. Here velocity is increasing, but now we will do velocity time graph when the velocity is decreasing with the time. Now we will do velocity time graph when the velocity is decreasing. So VT graph when velocity is decreasing. We can draw like this. Here velocity, here is time, we can take like this. Here velocity is decreasing with the time. Now if you take like this graph, this is velocity, this is time. Here we can take graph like this, like this, like this, in this way. Here velocity is increasing, then decreasing, then increasing, then decreasing. There is, you can say, non-uniformly accelerated motion. It is VT graph for non-uniform acceleration. Actually, when velocity time graph is not a straight line, we can say that is a body has got non-uniform acceleration. Now see another graph. Velocity time graph when body has initial velocity non-zero. See, whatever we were doing till now, everywhere initial velocity was 0. Now we will do velocity time graph when initial velocity is not 0. That graph will be coming like this. See here, this is velocity, this is time. We can take like this. See, this is uniformly accelerated because this is a straight line, but at the time 0 origin it has some velocity. We can say let it be u, because we represent initial velocity is u and we take final velocity is v. So, we can take this is the final velocity. So, this is the velocity time graph when initial velocity of the body is not 0.